This lesson is over synthetic division. Synthetic division is a streamlined and collapsed procedure. We only use the coefficients of the dividend, including any missing terms. And from the divisor x minus c, we only use the c value, or the 0. For example 1, use synthetic division to find the quotient q of x and the remainder r of x. For a, we have p of x equals x to the third minus 7x squared plus 13x plus 3. And for d of x, we're given x minus 2. Now, the p of x is your dividend, the d of x is your divisor. Now notice on the dividend it said to use the coefficients only. So let's identify our coefficients. The value in front of x cubed would be 1. The number in front of x squared is negative 7. The coefficient of x is 13, and the constant is 3. So if I take the coefficients, I will have 1, negative 7, 13, and 3. Now we said synthetic was very streamlined, collapsed, new, and modern. So the next thing we need to do is we leave a blank line under these values. We underline it, and we put a little piece in the corner. Now we're ready to look at the divisor. From the divisor, we use the c value only. In other words, what value would make that equal to 0? Well, x minus 2, the 0 would be 2. So the 2 is what goes in the corner. Now that synthetic is set up, let's see how it works. First, we start with the first value. The first number of 1 is brought down, and we place a 1 there. From here, we start a little dance. We do a pattern of multiply and add, multiply and add, multiply and add until we finish the problem. So here we go. The 2 in the corner will multiply the value of 1. So 2 times 1 is 2. This now starts our blank row. So we've done the multiply, now we add the column. What is negative 7 plus 2? Well, that's negative 5. Now we do it again. We multiply 2 times negative 5, which gives us negative 10. And now we add that column. 13 plus negative 10 is 3. Now we do it again. We multiply 2 times 3 is 6, and now we add. 3 plus 6 is 9. So congratulations, you just did synthetic division. But what in the world does that mean? Well, the last number is separated from everything else. The 9 is pulled off to the side. That's very important because the 9 tells you that is the remainder. The numbers on the other side are your quotient. So the question is, identify the quotient q of x and the remainder r of x. Well, from our quotient, we have divided out a factor of x minus 2. Since we started with x cubed, we have divided out a single x factor from it, which means the quotient has been knocked down a bit. It's no longer x cubed, it's now x squared. And so these are our coefficients. It'll be x squared minus 5x plus 3. Now we need to identify our remainder. Our remainder is identified as r of x equals 9. Now the question is x minus 2 a factor of the polynomial? And since our remainder was not 0, we would say no. X minus 2 is not a factor of the polynomial. Example B, we have x to the 4th minus 1 divided by x minus 1. Do you notice any missing terms? Since we have x to the 4th, we must include all the other exponents that are less than a degree of 4, which means I must see x to the 4th, x cubed, x squared, x, and then a constant. So we need to rewrite this, and when we do, it will be of the form x to the 4th plus 0x to the 3rd plus 0x squared plus 0x minus 1 divided by x minus 1. Now that we clearly see our dividend and all the missing terms, we're ready to write the coefficients. The coefficients would be 1, 0, 0, 0, negative 1. And now we set up our synthetic division. We draw the line and the little piece in the corner. Now it's time to identify our C value from the divisor. Looking at x minus 1, what would be the 0? Well, that would be 1. Now that your synthetic is set up, now let's perform the steps. First, the first value must be brought down, which would give us a 1. And now we start the little dance of multiply and add. So we multiply 1 times 1, which gives us 1. And now we add 0 plus 1 is 1. Now let's do it again. We multiply 1 times 1 and get 1, and we add. Now we do it again. We multiply 1 times 1, which gives you 1, and we add and get 1. One more time. We multiply 1 times 1, get 1, and negative 1 plus 1, well, that's 0. Now remember, the last number is separated, and the last number represents what? Well, it represents the remainder, and all the other values represent the quotient. Now the quotient can be rewritten as 1 degree less than the original problem. So the original started with x to the 4th, so our quotient will be 1x cubed plus x squared plus x plus 1. You may choose to have coefficients of 1, or you can choose not to show them, since 1 is understood to be an imaginary. So we have identified the q of x value. Now we identified the r of x. Well, in this case, the r of x will equal 0. Now the question is x minus 1 a factor of the original expression? Yes, x minus 1 is a factor of the polynomial, all because the remainder was 0. For C, we have p of x equals x to the 3rd minus 2x squared minus 8. For d of x, we have x plus 2. Now, notice on your dividend, do you see any missing terms? And for your divisor, to find your C value, remember, you use the 0 value. This problem? This is your try it. Let's see how you did. Hopefully you found the quotient to give you x squared minus 4x plus 8, and the remainder, r of x, to equal negative 24. Since the remainder was not 0, that means x plus 2 is not a factor. That brings us to the factor theorem. The factor theorem states for a polynomial f of x, if f of c equals 0, then x minus c is a factor of f of x. In other words, if your remainder is 0, then you've identified a factor. So example 2, factor the polynomial completely, then identify the zeros and x-intercepts. We're given f of x equals x to the third plus 5x squared minus 2x minus 24. Since it said to factor, you may be thinking of all the different forms of factoring. AC method, difference of squares, factor by grouping. And so we look at our given polynomial. There is not a GCF of all the terms, so we can't use that method. Now we have 4 terms, but it turns out factor by grouping will not work. We cannot use the AC method because it's not a quadratic. So we have to think back. Factoring a polynomial completely, factoring means to divide, to break into smaller parts. Well, since we know how to do division, we are going to divide by random values until we find something that works. So we try some number. We are going to use synthetic division since it's quick and easy. So let's set up our first synthetic division. We take the coefficients, which would be 1, 5, -2, and -24. And now we try a number. It could be any number. Let's start with a small value, such as 1. Now we do synthetic. We bring the first value down, and now we multiply and add. Multiply and add. Multiply and add. And then we look at our result. Did we get a remainder of 0? No, which tells us that x minus 1 is not a factor of the polynomial. So it just means it's not a factor, so we need to try another value. Instead of 1, let's try 2. So this time we're going to try 2, so we set the problem up all over again. We put the same coefficients of 1, 5, -2, and -24. We set up the corner, and this time we're going to try a value of 2. Now to do synthetic, we bring the first value down, and now we do our little dance. We multiply, add, multiply, add, multiply, and add. Now what do you notice? Well, our remainder in this case is 0. So since our remainder is 0, that means, yes, x minus 2 is a factor of the function. So on the right hand side, I have the original function. F of x equals x to the third plus 5x squared minus 2x minus 24. I identified a factor, which means I can now pull out an x minus 2 from the function. But what am I left with? Well, if I factored that out, that means I'm left with the quotient, the result of the division. Well, from synthetic, I have a 1, a 7, and a 12. Well, that means I have an x squared plus 7x plus 12. So I have factored it, but it must be factored completely. Notice x squared plus 7x plus 12 is a quadratic. So take a moment now to factor that trinomial. Hopefully you found the trinomial to factor into x plus 3 and x plus 4. So our completely factored polynomial is of the form x minus 2 times x plus 3 times x plus 4. We know it's completely factored since they're all linear or only have x's raised to a power of 1. The next part of the question says, then identify the zeros. Well, we can only identify the zeros if we have the factors. How many factors do we have in the function? Well, we have 3 factors, which means we have 3 zeros. The first factor, x minus 2, if I were to set that equal to 0 and solve, my 0 would be 2. My middle factor of x plus 3, if I were to set that equal to 0 and solve, I would find x equals negative 3. I take the last factor of x plus 4, set that equal to 0, and I would find x equals negative 4. So those are my zeros. Now from my zeros, I can identify my x-intercepts. X-intercepts are points and must be written as that way. So if my 0 is 2, as an x-intercept, that would be 2, 0. The next intercept would be negative 3, 0, and the last one would be negative 4, 0. Now, we did this by just trying random numbers, but surely there has to be a better method of finding factors than just trial and error. And there is, which brings us to the next section.